So, hello everyone. Let us welcome Kishor. So, we would like to welcome our next speaker, Kishor Sarode. Kishor is a QA manager at New Vision Software, and Kishor will be delivering an interactive talk session on leveraging generative AI to enhance software testing. So, welcome to Kishor, and the stage is yours.
Thank you, Abhay. And thanks to Rohit and Rahul as well. They have given the wonderful sessions on the efficiency and productivity using the GenAI. And I really like that the chart, the prompt which he has shown. Okay, so let me start with my quick introductions. So good afternoon, everyone. Welcome to ATI JTR 2024. Like all of you, I am also thrilled to be part of this exciting event. And let me introduce myself. My name is Kishor Sarode, a lifelong learner in software testing industry with over 16 years of experience. Currently, I work as a practice leader at New Vision Software, and recently I have started exploring AI and GenAI and its potential to revolutionize the software testing and elevate the software quality. So let me quickly share my screen without delay. Is my presentation visible?
Not yet. Yeah, it's coming. Some gray lines are coming.
Okay.
Yeah, it is here.
Okay.
And
So
still I can see some gray lines over your PPT. It is purposely or there are some system issues?
I think it's a system issue. So now, what about now?
Now it has been reduced from one side. It has been reduced more, but still we see some
Okay.
at the top.
Yeah, it's a screen sharing. It's showing screen sharing. You are sharing the screen. That
Okay,
window is there. Yeah.
no problem. Please continue.
Yeah, sure. Okay. So guys, I am going to discuss about the leveraging GenAI in software testing across the various use cases. So recently, Rahul and Rohit has explained the different use cases which they have implemented. Even I am going to explain the more about the different use cases which we can use during the software testing life cycle. So we'll go one by one. First, we'll see what is GenAI and artificial intelligence and machine learning and deep learning standpoint. So, you know, what is artificial intelligence is a way of making computer think and learn like a humans. It's like teaching computer to act smart by using the data and rules to figure the things out. So it enables to perform the tasks usually required human intelligence, maybe understanding the language, recognize the pattern, solving the problem, and making a decisions. So we need a artificial intelligence for that. And for machine learning, instead of giving a step-by-step instruction, so we can provide some data to the computer, we can train to that, and we can identify the pattern and make a prediction and take the actions on that. Okay. So machine learning is basically the type of artificial intelligence that allow computer to learn and improve on their own without being explicitly programmed for every task. Okay. So next point is deep learning. Deep learning is something we can excel at the task level. So for example, if I want to recognize the image, okay, so I can identify the faces in the photo with the help of image recognitions. If I want to convert the spoken words into the text, I can do that through speech recognitions, okay? And chatbot we can use for natural language processing. This is something we can use as a part of as a part of deep learning. Okay. Now, the point is GenAI. What is GenAI? GenAI is basically the subset of deep learning that helping us to generate the content like a text, image, code base on the input. Okay. And that is something we, instead of analyzing and classifying the data again and again, we can produce the something entirely new through the GenAI. Okay. Moving to the next slide. This is related to introduction about GenAI and its applications. Just now we discussed about the GenAI, and if we use the GenAI in the software testing, it will help us to enhance the test case creations, automate the test script development, and optimize the test data, right? So benefit to streamline the process and enhance the test coverage and improve the overall quality. So this is our software testing lifecycle, which is starting from requirement. I have considered unit testing, system integration, operation, and customer feedback. So here, if you see, if you are going to use GenAI in each phase of the software testing lifecycle, we'll get a different benefit. Okay. So we'll see what use case we can implement in each phase of the software testing lifecycle. Okay. So we can enable the creation of intelligent bot that bring insight by testing lifecycle by doing repetitive things, by replicating the repetitive human actions and handling some decision-making tasks and understanding the context, adapt to users and systems. Okay, so we'll see each page one by one. So let me go to the next slide, requirement page. This is one of the most important page where we are getting the requirement from the business users. Our product owner and business analysts are converting that requirement to detail level, and they're explaining into the converting that requirement into the functional part as well as non-functional part, so that development team, QA team can start working on that. This is one of the important page I can say, and this is the area. If you have not understood the requirement properly, then obviously there is the chances of missing we lose the quality as well. Okay. So these are the use cases we can implement, which from my perspective. So I have selected few use cases like defect predictor, test case failure predictor, defect backlog pruner, story point predictor. We'll see one by one. So defect predictor is the use case we can develop in early in the cycle by application of advanced machine learning technique on user stories and defect, and we can predict the count of defect which can be occur in the upcoming releases by using some key parameter. So for that, we need some historical data. We need some the test case execution log, which test case got failed and all. So this kind of project, if tested earlier, that level of data is really useful to develop this tool, defect predictor, which can help us to reduce the defect in the future or after testing or post deployment. Okay, so we can get the benefit in early stage of the life cycle. For that, we need historical data analysis. We can train the predictive modeling to analyze the new code, configurations, system changes, and predict areas with high likelihood of the defect. Okay. So code quality assessment is also necessary in this case so that we can integrate the code repository like GitHub to access the quality matrices. Then the last one, the defect prevention guidance. So if you use the defect prevention tool, it will suggest the best practices and solution to mitigate the predicted defect during the development phase. Okay. So moving to the next slide, next use case is we can develop is a test case failure predictor. These are the use cases from in the new visions we have categorized, which are planning to develop. Okay, so far we are not started working on it, but this is something plan which we are planning to work on that. So test case failure predictor is one of the use case which help us to perform the risk-based testing by identifying the failure test cases from user stories based on the pattern analysis. Which is help us to predict which test case are most likely to fail during the execution based on the historical data and test case characteristic and complexity, system changes, and code qualities. These are the factors which can help us to develop this test case failure predictor so that it can help me to identify the failure test cases from user stories of the similar pattern. Okay. Next one is defect backlog pruner. So defect backlog pruner will help me to streamline the defect management process. So, there are in the defect management, there are high chances that the same defects are raised by more than one testers. Okay, or maybe there are some debates are absolutely obsolete, low priority, or redundant also. Okay, so if you develop a debate backlog pruner, which will help me to focus on the critical issues and reduce the noise in debate tracking system. Okay. So next use case is story point predictor. So story point predictor is something like when you are using, when we are giving the story point. Okay. So we need to consider multiple factors, the complexity of the user story, the number of dependency of the user story, accepted criteria. So if you use the story point predictor use case in your bot, that will help me to identify, that will help me to give the right estimation or consistent estimations at least. Okay. So for that, I have to use some data collections and feature which we have performed in the similar way in the past. And we can cluster that in similar user stories like suppose the feature patterns have stories with comparable efforts, complexity. Then the story point prediction we need to consider in the past, which was the if the new user story added, the AI determined its cluster and assign the story point, which may be the average or medium story point of the similar stories. Okay. So this is continuous learning process because this is as long as we are getting the new user story, the model will get trained again and again, and so that it will give the more accurate user story point. So along with this, we can develop some Gen AI use case also like requirement drafting and refinement. Sometimes the customer is giving some high-level business requirement, and our product owner or BA has to write that the requirement into detail, well-structured, functional and non-functional way, right? So example, input a vague requirement like create user-friendly dashboard. Okay, this is our vague user story because we don't know user-friendly means what do you mean user-friendly here? Okay, so through GenAI, we'll get some actionable insight like layout suggestions or performance expectation or user roles. So that is something we can develop to requirement drafting and requirement. Next use case, we can plan for requirement validations using the GenAI. So GenAI can enhance the requirement validation process by automatically reviewing, analyzing, and verifying the requirement against the predefined standard. Okay, and against the pre-business goal and technical constraint of the user story. That will help me to provide the requirement validations for the clarity check, completeness check, consistency check, or maybe testability check I can do. Okay. And sometimes we need to follow some compliance and regulation. So that kind of the things we can do through the use case of requirement validations using the GenAI. Okay. And along with that, we can add a few more like the automated acceptance criteria. We are getting some acceptance criteria. For example, the system should allow user registrations. And in this case, AI can help us to find out the system must have some valid email address or password characteristic with special symbol. Okay. And once the registration is done, user should get the confirmation email. That kind of the acceptance criteria also we can write to the GenAI. Okay. Going to the next slide. This is for the development purpose. So these are the use cases: build verification predictor, test case failure predictor, and defect predictor. I'm not going to discuss about this use case in this slide at the moment because we will focus more on the testing point. So from testing side, so few more use cases we can develop a regression test optimizer. So regression test optimizer, the basic objective of this use case is to intelligently analyze the regression test suite and prioritize on select the most relevant test case for executions. Okay. So this will help me to identify the most relevant test case for execution based on the recent changes happening in the code or historical data or what is the business impact will be done to the test cases. So regression test case optimized will be help me to identify efficient and effective regression testing test cases. Okay. And this is possible through change impact analysis. So we have to analyze the code, then we need to modify the modules and features to identify the affected area. And then we have to map the changes to the corresponding test cases. Also, regression test case optimization will get the category of the test case, maybe high level test case or low level test case. Okay. Or it will also help us to prioritize maybe the rank test case based on the criticality of the functionality they cover, risk level of associated changes, and historical failure rates. Next one is this is also helping me to reduce the eliminations and historical data utilizations. Okay. So we'll talk more about this use case in coming slide. We have developed this use case for one of the customer, okay, and they have a 2 lakhs of the test cases, and they come with they come to us to automate that use cases. So we have developed the regression test optimization test case board, which we're going to discuss in the coming slides. The next one is duplicate defect identifier. As we discussed earlier also, there are high chances that the same defects can be raised in the systems by different testers. So this use case will help me to intelligently analyze and identify the duplicate defect in a backlog and during the defect logging by defect description steps and metadata. Okay. So for that, I have to use some semantic matching and some context awareness identification, some dynamic suggestions, and historical clustering. So based on that clustering, this kind of the group of existing defect into the cluster of duplicate, enabling agent to line up. Okay. This can be possible through these use cases. The next one is generate test script. So we have seen in the earlier session also, we can generate the test cases, manual test cases by considering the positive, negative, and edge cases by scanning to the requirement page. We have provided all user stories and the bot has developed the test cases on behalf of us. Okay. Similar way, we can use for automation script also by scanning through some object models and providing some accurate prompt so that uh, the chat GPT or bot can develop the test cases for us, automation code for us. For example, if I want to generate the code or verify that user can log with the valid credential. If I want to generate this code into the Java and I want to use some Selenium framework into that, so I can develop that, I can generate that code through the bot. Okay. Next use case is about the traceability mapper, which is helping me to map the requirement, test case, defect. This can be this will be help me to track everything from software requirement perspective so that I can have a linkage about all the requirements starting from requirement page to delivery page. Next use case is defect AI assistant. Okay. So defect AI assistant. So, one of the challenge for tester is that he found a bug, but during the execution time, he is getting the very less time to log a bug. Okay. Then he tried to copy paste the same information and he's not giving the detailed information in the defect. Okay. So defect AI assist bot can help us to log a bug on the behalf of QA so that it will give the detailed information about the bug by providing the screenshot. So this is the use case we are planning to implement in upcoming releases, and where we are planning to provide the test case, failed test cases on one which step it got test case got failed, expected result, actual result, screenshot, and the environment. So based on this input, the defect AI assistant bot will help us to log a defect. This is very simple use case we are going to tell you, which we discuss. But along with that, we can provide a video also, and that chat bot can convert that video and will log a bug on the behalf of that. So for that, we need defect auto documentations, smart triage categorization. So if we implement this defect AI assist use case, so it will help us to smart triage and categorization. We use AI, which will assign the priority and severity based on the defect impact analysis. And it will be categorized like it may be the functional error, maybe API testing problem, or maybe performance or security issues. Okay. So this will also help me to find out the root cause of the bug. Okay. And if it is duplicate in the system, it will highlight this bug is already duplicate into the systems. Moving to the next slide now. So GenAI can be used in predictive defect detection. through static code analysis, we can use the GenAI for predictive defect detections. So here is the objective or that to leverage GenAI to enhance the static code analysis for predicting potential defect by analyzing the code pattern, structure, and historical data, allowing team to identify and address the defect early in the development lifecycle. So the key feature of this use case will be, so we can have a code pattern recognitions. So user use generative AI to detect the problematic patterns in the code that are often associated with the defect and will provide the best practices for the poor designing practice. Okay. Then predictive defect detections. So through this static code analysis, so at the moment the developer have they don't have problem to fix the current issues, but they are not aware about which issue can be introduced because of the current fixes. So the static code analysis use case will help them to identify defect prone area in the future because of the changes happening in the recent changes. Okay. So moving to the next slide. AI powered test automations. So AI powered test automation use case is more popular use case nowadays, and we just recently seen that test case generation part also, automated test script generations and test suite optimizations. So I just mentioned the example that we have one of the customer is asking to automate 2 lakhs of the regression test cases. Okay, so for that we have implemented regression test suite optimization by categorizing the test cases into the duplicate test cases. Duplicate number of steps are there, and almost duplicate steps are there, or unique steps are there. So these number of categorization we have done, and we have developed that use case that we are going to discuss in the coming slide. Next use case we can develop in the part of automations, AI power automations, that test data generation. You know, some banking project, they can't use the productive data, production data as for testing purpose if they want to check some overdraft scenarios or account balance scenario. So in that case, the test data generation can help us to generate the synthetic data which we can use for the testing purpose. Then the next one is automated test execution and result. So one of the problem statement for the QA that if they run the automation script overnight, so what happened? Let's consider we have executed 1,000 test cases overnight, and next day we through CI/CD on multiple machine we executed 1,000 test cases, and next day when you come and we seen that 400 test cases got failed. If you going to find the reason why 400 test cases got failed, so of course it will take time because we need to go to the each automation log and we need to find out the reason why that particular test case got failed. And then we need to categorize, maybe it may be the code changes or maybe script issue or maybe there is some bug. So through AI, we can have a dashboard, or through find out the that bot will go to the each automation log and will categorize based on their training. Based on the training, it will categorize whether it's a script issue or maybe application issue or maybe code issues. Okay, and it will help us to log a bug in early instead of wasting the time to find out the why that particular test case got failed. Okay, this will also help us to detect prediction and prevention also. Sorry. Then one more use case is intelligent test failure analysis. So generative AI can automatically analyze the test failure to provide insight into the most likely causes of failure, correlating trace result with past defect, environmental issues, and other variable. So let's consider input we are provided as a failure logs and past defect history. So what output we get? The report explaining the possible causes of failure. Maybe test failed due to recent API change, or maybe test failed because of the network issue. This kind of the intelligent test failure analysis can be done through GenAI. Okay. So automatic code generations. So automated test case generations can be possible to code analysis, test case designing, and test executions. Now, continuous testing with AI. So major changes problem is, so one of the challenge that frequent code changes happening and it is difficult to manually run all the test cases every time. This is one of the regular problem or common problem for every testers. Okay, so this is testing process will take in the time consuming and can lead to delay in release cycle. So what solution we are providing to continuous testing with AI? So we can have a AI driven test case prioritizations. It will give the priority which is high priority test case or critical test case. So we need to pick the test cases so and execute it so that we can more focus on the required part instead of putting the more efforts on the on unnecessary features. Okay. And automated test executions and feedback loops. And self-healing tests can be possible through continuous testing with AI. So AI-powered tools detect changes in the application interface. For example, UI element or some workflows or automatically update the existing test script. To repeat these changes, this minimize the maintenance effort and ensure that tests remain valid despite the frequent code changes. Okay. So again, as we are going to use the automated test generations, intelligent test selections, and dynamic test execution, this will help us to improve the test coverages and efficiency. So this is the common difference between the AI-driven root cause analysis. So as we have implemented the traditional way, manual, of course, it will take the lot of time, manual investigations. And as we are doing the manual investigations, it will take a time. It's a time-consuming process. And for manually, if you are performing the task manually, of course, it will take more time. So there is a limited scope to complete the activity. But through AI power, we can automate the analysis of the log and data, and which is helping us to do the fast and accurate identification of the root causes. And there is no limited scope. We can have a comprehensive analysis across the entire system. So this way, we can integrate the AI into the QA part, planning page, development page, testing and deployment page. Okay, so AI powered test case optimization. This is one of the problem statement. Just now we fix it. See, one of our client, they have a big four audit firm, and they are coming with the problem that they have 2 lakhs of the manual regression test cases for business critical application, and they want to automate that test cases. Okay. So the challenge was optimizing the test suite to remove the duplicate and redundant. Okay. And find out the automated test cases. It was really difficult for us because go through the 2 lakhs of the test cases manually. Of course, it's a time consuming task. Okay. And it's not a feasible also. Then shifting through the 2 lakhs of the test cases needed some automation provided to in the even efficient manner. Okay. So what solution we have provided? We have we have developed a bot. That bot is helping us to identify how many test cases are there which have a repetitive steps. Okay. So that how many repetitive we have categorized the test cases into the duplicate, almost duplicate, high similarity, low similarity, and unique. This kind of categories we have done. So this kind of category help us to identify the test cases count, which is we require to optimize it. Okay. So let me show you the pie chart. So in this pie chart, you can see that we have identified duplicate count is 12%, almost duplicate is 10%, high similarity 4%, similarity, low similarity 70%. This is the way we have calculated all the test cases on the 2 lakhs of the test cases. Okay. But as this is internal project we have implemented on that, we have used the 608 test cases, and we have seen that out of 608 test cases, only 273 test cases are unique, and rest of the test cases how some category like almost duplicate was only 15, highly similar, their optimized test case count was 14, and similar way moderate is similarly 18. Now, if you are interested, how we are saying that this is the duplicate, when we are saying that 100% duplicate means, so all the steps are common in that particular test cases. So there are chances that same test case written by more than one tester. So maybe they have not maintained traceability there. So that's the reason duplicate test cases are possibility. Then, but there were 72 test cases in our internal project, out of 608, which were duplicate. So we don't have to write any single test case for that. So in this way, we have achieved the 27% of optimizations here. Okay, so let me tell you the example how it represented by our boat. So on the boat, we have given the dash. Boat has represented the dashboard first, and then it gone to the category like this. Suppose the almost duplicate category is original test case one. First test case have a this number of test cases which have a same steps. These are the 6 steps that are common for each duplicate test cases for respect to original test case 1. Similar exercise happened for the rest of the test cases, test case 13, test case 16, and 64. And these are the duplicate test case ID, and these are the duplicate test steps. So this is helping us to reduce the count and take the optimized test cases for the automation purpose. Next use case is we have implemented one-touch failure analysis report. As I mentioned, when we are running the automation code, so of course it takes time to execute overnight. And next day we have seen that out of 1,000 test cases, 400 test cases got failed. And if I go through the automation log, so of course it will take 3 to 4 days to understand why a particular test case got failed. So what we have done, we developed a bot which is helping us to go through the each automation log and for failure test case and categorize the test case failure test case into the code issues or application issues. And this is helping us to identify the failures or log the bug in the early stage. Okay, instead of spending 3 to 4 days on particular activity. So benefit we realize from this, we got 90% efficient analysis time reduced from 96 hours to 5 minutes. And defect identification, we found the defect in 90% faster. Defect detection rate is there. Okay. And also, as we found the bug 3-4 days before, so we got the priority also and time also. So task prioritization means, so we know which bug is most important because that particular test case got failed and that coverage of the test case also. So in this way, we have implemented this test case. Now we'll see the future of GenAI in software testing. So first one is hyper automation. So expansion of automation testings where AI-driven bot can decide which test to run, how to prioritize them, when to execute them without human involvement. Then growth of no-code, low-code automation platform. This can be possible in the future, okay, through our hyper automations. Then future trends in predictive analysis in software testing. So, the IoT or age testing predictions can be possible through predictive analysis in the software testing. Okay. Then also through GenAI in the future, it will be possible that fully automated testing strategy when predictive analytics guide test execution and defect predictions. And last one is the AI human collaborations in software testing. So GenAI will work alongside the human tester, enhancing their capability and providing the valuable insight. This is all about my presentations. Thank you for giving me time for this.
Thank you, Kishor.